So, last day, we studied the exponent in 2 of the 5 laws. Those 2 laws were multiplication and division of exponents. Take, for example, the following. -2 squared times -2. Now, this is going to combine 2 quick rules and laws that we kind of came up with last day. So, anytime you're multiplying 2 numbers that have the same base, if one of the numbers is missing an exponent, put a 1 on it. Now, next, what I'd like you to do is I'd like you to calculate the solution. And we get -2 to the 2 plus 1, which is equal to -2 to the 3, which is, well, -8. The basic rule for multiplication of exponents is a to the m times a to the n is equal to a to the m plus n. Essentially, multiplying exponents means that we're going to add exponents. Now, let's take a look at the following example for division of exponents. 3 to the 5 divided by 3 to the 2. What I'd like you to do is I'd like to calculate these solutions. Pause right here and do it, and then we'll see what our solution is. Well, we get 3 to the 5 minus 2, which is 3 to the 3, which is 27. The basic rule for division of exponents is a to the m divided by a to the n is equal to a to the m minus n. Essentially, when we divide exponents, this means that we must subtract the exponents. Today we're going to study the third rule, and we're going to go through 2 examples to see how this works. So, here we go. So if I have the following. If I have 3 to the 2 raised to the power of 3, let's use the old rules that we had before. Basically, what this really means is the following. We have basically 3 to the 2 multiplied by itself 3 times. Based on the multiplication rule, if you think about it, these are all just multiplications. So what this really means is that we have 3 to the power of 2 plus 2 plus 2, which is equal to 3 to the 6, which calculates to 729. Now, you know that this part and this part are the same. But if you think about it, we could also have thought about the multiplication of the 3 to the 2 as the same as this. The reason we have 3 to the 6 is because 2 times 3 is also equal to 6. That just combines these 2 parts into literally one step for later. Now what I'd like you to do is I'd like you to try the next problem. -2 to the 2, all raised to the negative 2. So again, that's negative 2 to the exponent 2 raised to the 2. Let's see what you get. Let's see if you can simplify very quickly. Pause here. Now, because we have negative 2 raised to the 2, it's basically multiplied. So we have 2 times 2, which gives us negative 2 to the 4. And the reason for this is exactly the reason we took a look at right here. Now negative 2 to the 4 is negative, is it negative 16 or positive 16? If you guessed it's positive 16, you're correct, because we have an even power. We have an even power that's being applied to the 4. If it was an odd power, say a 3, a 5, or a 7, then you know our overall answer would have been negative. But in this case, our even power causes the cancellation of all the negatives. So the basic rule for power of a power when working with exponents is this. If I have a to the m raised to the n, then we're going to write a to the m times n. So basically, when we have a power inside a bracket raised to another power, we have to multiply the exponents. All the rules that we did before, for example, if there were any numbers inside this, you would have to make sure, if there were any numbers as bases and a letter as a base, and there was no exponent, all you have to do is put a 1 on the exponent, and then this rule still applies. If I had a fraction in there, it would still apply. So just take that down quick and think about that. Now, let's just quickly put our equation for the rule of a power of power. We're going to have a to the m raised to the n is equal to a to the m times n. Let's go and put n as blue. I don't like that red there. Now, we're going to go over some examples. So we're going to see problems where they say write as a single power and then evaluate. So basically, we're simplifying the exponents into one number, and then later on we're going to use our calculator to calculate the final answer. So I'm actually going to do a couple of steps to kind of make your life easy, so you see where the numbers come from, and then when you get better at this, you can drop certain steps. But you need to practice this tonight. If you choose not to, you're going to have issues, because we're going to be blowing through this unit very quickly. Here we go. So 3 to the 2 raised to the 4 equals 3 to the 2 times 4. And we know that 2 times 4 is 8, so we have 3 to the 8. When we multiply that, when we use our calculators to do the final answer, we get 3 to the 8 is 6561. Now, let's do a problem where we have a bracketed exponent, a bracketed base raised to some new power. So here we go. Negative 4 raised to the power of 2, again raised to another power of 2. So when we write this, I'm going to show you what you need to remember. The inner bracket always has to be there if we have a negative power sitting inside here. So I got -2. This is -4 raised to the 2 times 2. And this ends up being -4. Notice it's still in brackets, raised to the 4. And if you notice, I have an even power here. If I have an even power and a negative base, is that going to be overall negative or positive? Think about it, and then I'll show you the answer. Okay, here we go. Here's our answer. We go -4 in brackets raised to the power of 4. It's very important that when you type this stuff into your calculator, you write it exactly as you see on this second last step, or else you'll get the wrong answers. So -4 in brackets raised to the power of 4 is 256. Now, what we'll do next is we'll take a look at examples C and D. Now, C and D will have a mixture of two things. Let's see what those look like. So now, I'm going to force you to use brackets in certain instances. So sometimes when you get equations, you'll get something that looks like this. -2y in brackets raised to the power of 5. Now, we're going to make it just a little more difficult. We're going to put an exponent 4 right here on our y. Now, I want you to imagine what this really means. Remember how I told you that if there was no power on something, we had to make sure that there was a power of 1 on it inside the bracket. This is one of those instances. If you take a look at this problem, we have, well, -2 needs an exponent on it. So our exponent for that is literally going to be the number 1. And then we have already a power on y to the 4, so we don't bother with that and we leave that alone. So now, when you apply the power to anything that has multiple things inside its brackets, you put brackets around the stuff that don't have exponents and then put them to power 1, just like we did with our -2 in our original bracket and raised it to the power 1. Then what we have to do is we simply have to take our powers. We have to take our power of 5 and we're going to apply it to everything that's inside the bracket. We call that kind of like a distributive property of exponents. So basically, we're going to have 2 to the 1 times 5 and 4 and y to the 4 times 5 as our result in our next line. So we're going to get the following. -2, well, I'm going to write this in red, 1 times 5. And then also, we have y raised to the 4 times 5. So if you think about it, if there's an exponent outside the bracket, basically the exponent is applied to everything that's inside the bracket. Anything that is inside is applied with a -5. So when we go to simplify, we look at the numbers that are raised and we simplify that to be -2 to the 5 raised to the 5, because 1 times 5 is 5, and then we also have y to the 20. When we simplify, Negative 2 to the 5 is negative 32. Now the reason why that's negative 32 is because we have an odd power applied to a negative base, and that causes us to have a negative number. And remember, when you punch this into your calculator, you need to make sure that you type it in exactly as you see right here. Bracket negative 2, bracket raised to the 5. And then we have, well, nothing's left to do for our y to the 20, so we just leave y to the 20. And we're done. Now, last but not least, we're going to take a look at a problem that has a fraction in it. So here we go. 1/2 raised to the negative 2 raised to the negative 1. So every time you see a problem like this, in order to simplify your work, you always want to multiply the exponents together because it's power of a power. So our base is still 1/2, and we leave it in a bracket. And then we're going to show the multiplication of negative 1 and negative 2. So I'm going to put negative 1, negative 2. I'm going to write times negative 1 on here, and I'm going to use that as my result. I need you to use your calculator in this way. If I have a negative 2 and a negative 1, put the numbers together in brackets as well and multiply those exponents. So now, by simplifying, we're going to get 1/2 raised to the power of 2. Now, just like before, if I have a fraction, that means the 2 is applied to the 1 and the 2 is also applied to the 2. So we end up with 1 squared over 2 squared when we distribute. So we get 1 over, well, 2 squared is 4 is our final answer. Your homework is on page 32, number 2, 4, all the way to number 8. These are pretty simple things. It's just multiplying. Each one of the questions that we've done talk about each one of the different types of problems you will see. Don't be afraid to ask your teacher for solutions or help.